Have you ever stopped and thought about how the moon, this seemingly quiet, distant orb in the night sky, actually plays a huge role in shaping life right here on Earth?
It's true. It's way more than just a pretty face. Welcome to Cosmos in a Pod Space and Astronomy series. Today we're diving deep into the fascinating and often unseen connection between the moon and Earth. Okay, so we all know the moon is responsible for the tides, but what else does it do? What other ways does it affect us down here? It feels so far away.
That's a great question, and it really highlights how much we take the moon for granted. To answer your question, the moon's influence is actually much more profound than many people realize.
Okay, I'm intrigued.
Yeah.
Tell me more.
Well, for starters, it's important to understand that the moon isn't just any moon. It's surprisingly large compared to Earth, the largest moon-to-planet ratio in our entire solar system. And even though it's about 238,000 miles away, its gravitational pull is strong enough to exert a significant influence on our planet.
So it's big and has gravity. How does that actually play out in our everyday lives? Let's start with the most obvious example. Tides. The moon's gravity pulls on Earth's ocean, creating bulges of water on the side of Earth closest to the moon. These bulges are what we experience as high tides.
Right, high tides. But aren't there different types of tides? What about the low tide?
Exactly, you're right. There are different types of tides, and they're all influenced by the complex interplay of gravity between the Earth, the moon, and the sun. On the opposite side of the Earth from the moon, the gravitational pull is weaker. This creates another bulge, and that's where we get low tides. It's like the Earth is being stretched a bit, with high tides on either end.
So the moon is basically tugging at the Earth, like a cosmic plaything.
You could say that, but it's not just about the moon. The sun's gravity also plays a role in tides, though its influence is weaker because it's much farther away. Now, when the sun, moon, and Earth are all lined up, like during a full moon or a new moon, their gravitational forces combine. That's when we get those extra high tides called spring tides.
Ah, that explains why the tides seem so much higher during a full moon. It's like the ocean is trying to reach out and touch it. But I've also noticed that sometimes the high tides aren't as high. What causes that?
Those are called neap tides, and they occur when the sun and moon are at right angles to each other, like during the first and third quarter moons. In this configuration, their gravitational forces partially cancel each other out, leading to less extreme high tides. It's like they're having a cosmic tug of war, and neither one is winning.
So the moon is basically conducting a cosmic ballet with the oceans. It's amazing how this distant object can have such a tangible effect on our planet. But it's not all about water, right?
Absolutely not. And this is where it gets even more interesting. The moon also plays a crucial role in stabilizing Earth's axis.
Wait, hold on. What does that even mean?
So you know how Earth is tilted on its axis at about 23.5 degrees?
Yeah, that's what gives us our seasons, right?
Exactly. But without the moon, that tilt could swing wildly. From 0 degrees to 85 degrees. Can you imagine what that would do to our sealkins?
Whoa, that sounds chaotic. What would that kind of instability mean for life on Earth?
It would be disastrous. Imagine going from scorching summers to freezing winters in just a few weeks. Agriculture would be impossible, and many ecosystems would collapse. Thanks to our lunar companion, our planet's tilt remains relatively stable, giving us the predictable seasons that we rely on for everything.
Okay, so the moon is like Earth's personal trainer,
Yeah.
keeping us balanced and in check. What a fascinating thought. Is there anything else it does for us?
Oh, there's more. You might be surprised to learn that the moon is actually slowing down Earth's rotation.
Hold on. Are you saying the moon is messing with time itself?
In a way, yes. It's a phenomenon called tidal braking. As the moon's gravity tugs on Earth's oceans, it creates friction. And this friction, over incredibly long periods, gradually slows down our planet's spin. It's like the moon is very slowly applying the brakes to Earth's rotation.
Wow. How much slower are we talking?
Well, billions of years ago, a day on Earth lasted only about 6 hours. Thanks to the moon, we now have a luxurious 24 hours to enjoy. And the days are still slowly getting longer.
Wait, so the moon is actually lengthening our days. That's wild. Does it do anything else besides mess with time?
Believe it or not, it does. Aside from its role in tides and axial stability, the moon also provides a subtle but important source of light at night. While moonlight is much fainter than sunlight, it's enough to illuminate the night sky and plays a crucial role for nocturnal animals.
So moon is a timekeeper, a nightlight. What a multitasker. It sounds like the moon is even more impressive than I initially thought.
It really is, and we haven't even touched on how it may have played a role in the very origins of life on Earth.
Okay, I'm on the edge of my seat. Tell me more.
You see, the prevailing theory about the moon's formation is something called the giant impact hypothesis.
Okay, that sounds intense. Tell me everything.
The idea is that about 4.5 billion years ago, a Mars-sized object, we call it Theia, slammed into the early Earth. Imagine a cosmic collision of epic proportions.
Whoa, a cosmic fender bender. I can't even imagine the kind of energy released in an impact like that.
It would have been more like a cosmic cataclysm. The impact was so powerful that it flung molten rock and debris into space. Over time, that debris coalesced, eventually forming the moon.
So the moon was literally born out of cosmic collision. That's incredible. But an impact that big must have had some pretty serious consequences for Earth.
Absolutely. The giant impact wasn't just a one-off event. It had profound and lasting effects on Earth's evolution. Scientists believe that this collision might have been responsible for shaping Earth's crust, influencing the development of our atmosphere, and even contributing to the formation of our oceans.
Wow, so the moon isn't just our celestial neighbor. It's also kind of like our cosmic sibling born from the same chaotic event that shaped our planet. It makes you wonder, would life on Earth even be possible without that impact?
That's a question that scientists are still exploring. But it's certainly possible that the moon played a crucial role in creating the conditions that allowed life to emerge. The impact likely brought a unique mix of elements to Earth, and the moon's gravitational influence has helped to stabilize our planet's environment over billions of years.
It's mind-blowing to think that this object we see in the sky every night
Yeah.
might be one of the reasons we're even here. It's like a silent guardian watching over us from the beginning. But, speaking of the moon's influence, I've heard that it's slowly drifting away from us. Is that true?
It is true, but don't worry, it's a very slow process. The moon is moving away from Earth at a rate of about 3.8 centimeters per year.
3.8 centimeters per year. So like the same rate that my fingernails grow. Doesn't seem like much.
It might not seem like much on a human timescale, but over cosmic time it adds up. Billions of years in the future, the moon will be significantly farther away from Earth than it is today.
So what happens as the moon gets farther away? Will its influence on Earth diminish? What will that mean for us?
Over very long timescales, the moon's gravitational pull on Earth will gradually weaken. This means that tides will become less pronounced, and Earth's axial tilt might become a bit less stable.
Will days continue to get longer as the moon moves farther away?
Yes, the process of tidal breaking will continue, but the rate at which Earth's rotation slows down will decrease as the moon's gravitational influence weakens.
So a moonless Earth is not something we need to worry about in our lifetime. But it's
Yeah.
fascinating to think about how our relationship with the moon is evolving over cosmic time. It makes you wonder, are there any other, maybe less obvious ways that the moon influences our planet that we haven't talked about yet?
There are always more mysteries to uncover. Scientists are constantly exploring new ways in which the moon might be connected to Earth. For example, some research suggests that the moon's gravitational pull could have subtle effects on Earth's internal processes, like plate tectonics or volcanic activity.
Wow, so the moon might be influencing things happening deep inside our planet. It's incredible how much we're still learning about this seemingly familiar object in the sky. I'm starting to realize that there's a lot more to the moon than meets the eye.
Exactly, and that's what makes studying the moon so fascinating. It's a constant source of new discoveries and insights into the complex workings of our planet and the universe as a whole. It's a reminder that even the things we think we know well can still surprise us.
It really is. I feel like we've only scratched the surface of understanding the moon's influence on Earth. It makes you wonder what other secrets this celestial body holds.
Well, that's the beauty of science. It's a never-ending quest for knowledge and understanding. And with every new discovery, we gain a deeper appreciation for the interconnectedness of everything in the cosmos.
At the beginning of this deep dive, I thought I knew a fair bit about the moon, but I have to admit you've opened my eyes to a whole new level of understanding. It's amazing how something that seems so familiar can actually be so complex and mysterious. As we wrap up, is there a key takeaway that you want our listeners to remember about the moon's unseen influence on Earth?
I think the most important thing to remember is that the moon is not just a passive object in the night sky. It's a dynamic force that has shaped our planet's past, influences our present, and will continue to impact our future. It's a vital part of the intricate web of life and cosmic forces that make Earth the unique and vibrant planet we call home.
I love that the moon is not just a pretty face. It's a vital partner in the cosmic dance that makes life on Earth possible. Well, this has been an absolutely fascinating deep dive. I feel like I've gained a whole new appreciation for our lunar neighbor. For our listeners who are eager to continue exploring the wonders of space, where can they find more cosmic adventures?
Be sure to follow and subscribe to Cosmos in a Pod for more deep dives into the mysteries of the universe.
And don't forget to check out our YouTube channel for stunning visuals and even more cosmic content. Until next time, keep looking up and stay curious.